Okay, Avery, if we look at this data, I'll show you it's something from a sheet that I do with my students. So arm span versus height. I know the relationship in advance. The students don't, you don't. So if we go back over here, I've just typed it in. Um, as you see, we could go into the wrench and make the low bound for X 150, the high bound 190, the low bound 160, the high bound 190. We could do that. Um, I haven't particularly done that, so if we scoot over here and look at the wrench, it's just got some stuff in here, right? That's okay. Um, but let's just say it just shows up like this. I think there's something interesting here, and that is you can try different shapes. Okay, so let's say I have no idea what this is and I'm on the test. Okay, so I'm going to use the expression. I'm going to say y1 squiggly a, and then what could it be? I could say um, x1 plus b. I could say that. Okay, well, that's possible. Depending on whether or not 0, 0 is a data point, and this was arm span versus height, so I'm assuming if I have 0 arm span, I have 0 height. So I think 0, 0 should be a point, but let's try another one, okay? So we could try quadratic, all right? So I could say y1 squiggly a x, and then I could come right here and say squared. Oop, gotta be x1, doesn't it? x1 squared. Okay, well, that certainly doesn't look right. I don't think it's the quadratic, do you? Okay, so what else do we know? So we know linear, we know quadratic, we know inverse. So I could say y1 squiggly a let's see, inverse. So that would be x1, and then I could choose square, but it's not squared, it's, let's see, so we need x1 squared, which is really, but we don't need it to be squared, we need it to be to the -1. Okay, so that's an inverse. This purple one right here. Well, that doesn't appear to match many points. So I think inverse and quadratic are not good. Okay, so I think I'm just going to lose them. You can run the video back if you want to see them. So linear is still there, but I really feel like it should be coming through 0 on this, and it's not. So let's try one more, which is a root. So really you know 4 that you're kind of working with. And so if I say y1 squiggly a, and then square root, so I'm going to come down here, square root of x1. Oh, look at that. Do you see the black line? That starts at 0 and it goes through all my points. So now I think I might lose this linear plot because it doesn't go through 0. And I can just look at this, and that's a nice fit. So I guess what I want to say to you is if it isn't obvious, you can try different things until you see the fit. And the only two that were even players here for this data set were linear and root. And when I got them both on there, remember, you have to think about what you're graphing. If there is 0 of one, is there 0 of the other? If you have 0 arms, is it likely that you have 0 height? I say yes, so that makes 0, 0 a real data point. If in doubt, Avery, assume 0, 0 is a real data point, and then that linear thing kind of came in up here, which I don't think is a good fit for you. So if we look at this, that's a root. What this means in words is that as y increases, the square root of x increases. So with any of these equations, if you want to be able to say it in words, you just say as y increases, and then you look at whatever you've done to x, the square root of x increases. Or if you had x to the negative 1, you would say x to the negative 1 increases. Or if you had x squared, you would say x squared increases. So as y increases, whatever happens to x increases.